Hi everyone, this talk is about how to use Nomad event stream to monitor your cluster activities. With the help of Vector, we'll collect and process these events and then ultimately use Grafana Loki to analyze them further. This talk is divided into three parts. In the first part, we'll understand what are Nomad events and then how do we connect to a Nomad event stream. In the second part, we'll see how the Nomad event sync collector program works. This is a program that I wrote in Golang and it listens to a Nomad event stream and outputs these events to sync. We'll use Vector to collect these events and transform these events and then store them in Grafana Loki. In the third part, we'll cover some real-world use cases that you can use Nomad event stream for to monitor your cluster and set up alerting based on certain type of events that are generated in the cluster. Hi, my name is Karan and I'm from India. I work as a software engineer at Zerodha, which is India's largest stockbroker. I also regularly blog about things that I'm learning at mrkaran.dev. So before proceeding to know about Nomad event stream, we need to have a basic understanding of what do we mean by an event. So this is an example of a Redis deployment where you can see certain key components are transitioning their state from state A to state B. For example, allocation here went from pending to running, and evaluation status also changed from pending to complete. The deployment also became successful in the end. So all of these state changes are applied via a central component called finite state machine, or FSM for short. In a Nomad cluster, no matter whatever operations are involved, any operation which is related to a state change undergoes via this FSM. So these state changes are logged and they are pushed as events to a central entity called event broker. This event broker is common across all the servers, so it doesn't matter whichever server you connect to, you'll get a consistent and identical set of events in the stream from the event subscription. So an event basically is a JSON event is represented by a JSON object which has certain keys like filter key, index key, namespace, topic, and type. These are all the keys which will give metadata about what the event is, and there is a key called payload. The contents of this key are contextual and it depends on what that particular type of event is. So in this screenshot, this is a evaluation updated type event. So the payload information will contain information of that particular evaluation. So now that we know that event is basically a JSON object, a stream of events is also similar to that. It's a collection of these JSON objects separated by new line. So these are called ND JSON objects or new line delimited JSON objects. And when you connect to an event stream, all of these events are coming from an event broker. This event broker stores these events in memory, and Nomad by default stores up to last 100 events in the memory. If you wish to tweak this configuration, you can do that by changing event broker properties in the Nomad server config stanza. In the previous slide, you also saw that there is a key called index, and this is a unique index which is associated for each event. So this acts like an offset. So imagine you have a consumer which is consuming these events, and suddenly the consumer connectivity breaks and it stops consuming these events. Now when the consumer tries to come back up, in order to not replay all the events from the beginning in the event queue, it will give an index which will act as an offset, and only the newer events since that index will be streamed in that subscription queue. So this helps the consumer to not get the duplicate events again. Events can also be filtered using topic or namespace. So for example, you are only bothered about a deployment event. You can filter those events by that topic, or if you have production and dev namespace in the same cluster, then you can also filter only for a particular namespace that you're interested in. So if you already have if you already have a Nomad cluster running, you can subscribe to these event stream over an HTTP API. So let me demonstrate how that works. I've started a Nomad cluster over here, and this is running in a dev mode. Now what we'll do is by the time it's running, we'll run that curl command. So you can see these are different events that it has generated. These are all the initial events when a node registers in the cluster. This is the event demonstrating that topic node, type node registration. Now you saw how simple it is to collect these events, but we need a reliable way where we can collect and store these events. Right now we are just listening to the incoming events, but we need a way to store these events as well. So that's where this program called Nomad events sync collector comes in, where I use a Golang client library provided by Nomad to initialize the Nomad API client, and that client is used to start a subscription queue for the events. So for the event stream, so that events are constantly coming in the queue, and there are background workers listening on that queue to process these and flush them to upstream providers. This provider is a generic implementation, interface implementation, and so far I have implemented the HTTP sync provider. What that means is that the events will be collected and batched together and then sent as a HTTP post request, and the events will be in the post body of that request. So the upstream API then can handle them however they want. So this is the gist of what this program does. Here you can see these are the Nomad servers which it has connected to, and the events are coming in. They are sent to the internal sync queue, and workers are listening on that sync queue and then periodically flushing and batching them to the upstream providers. So I'd like to do a small, and this code is also available on GitHub if you wish to explore further. So I'd like to do a code walkthrough of this, how this whole thing works. I have the code ready with me. So app.start is the entry point of this application. You can see we are looping over a list of topics. This list of topics comes from the config. So you can see we have these 5 topics over here: deployment, allocation, evaluation, job, node. For each of these, this topic, it will start a subscription, event subscription. What this function does, subscribe function does, is it will initialize a stream channel, which is basically a Golang channel which consists of events. So we initialize that channel, and then we run this handle events function. This is a blocking function because it infinitely loops over that particular channel to listen on newer messages which are coming in that channel. So over here in this case block, we can see if the newer message has come, we'll process it. So by that, what I mean is, we'll firstly ignore all the heartbeat events. Heartbeat events are just empty messages which just tell us that the connection is alive. So, but we don't need to record it or log it anyway. So we are just skipping it. The actual event, we are adding it to our sync. So sync.add is another queue, s.queue here, and this is another channel which also consists of just events. Over here you can see the data structure is channel and API.event. And in the starting of the application, when the application boots, we spawn some workers. So these are Go routines which are running in the background, and they are processing these events as and when they are coming into the queue. So by processing events, what I mean is that they are again listening on that particular internal sync queue, and they are flushing these, they are batching these events. Now this is very important here, and they are not immediately sending that event to upstream. This we do it because let's imagine you have a noisy Nomad cluster where there are a lot of updates happening constantly, or if the Nomad cluster consists of large number of nodes, and these nodes are coming up and down regularly. So basically all of these will generate a lot of events, but we don't want to put burden on our upstream API, which is the HTTP provider. So what we do is we'll batch these events together. Now batching strategy is twofold here. First strategy is number of events. So we check if the batch number of events in the batch has reached batch event capacity, then we'll flush those events. The second strategy is based on a timeout, which means that if the number of events is less, but the idle timeout has come, then we'll flush those events. So just an example to give, over here events count as 5. So this is the first batching strategy, where if the number of events exceed more than 5, a batch will be prepared and flushed to the upstream provider. Or the second strategy is, if the idle timeout, which is 5 seconds, if it has passed over that time period, it will then flush it. So either of these condition, whichever of these condition is true, the upstream provider will get those events. So for pushing those events, we use this function called w.flush. So flush is basically it's just sending those events to this provider on that push method. So provider is a interface implementation, and you can write any kind of provider which will have these 3 methods to satisfy this interface. Over here, the push method is a main method, and you can see the HTTP provider implementation for that push method. What it does is, it's pretty simple. It initializes a new HTTP post request, and all those events are sent as post body. So once that is done, it is left to the upstream provider to deal with those events however they want. So far you have seen the first part of the pipeline where we are collecting those events, and then we are just sending them over HTTP API. Now to plug the other parts of the pipeline, we use this tool called Vector. Vector is a fantastic utility where it can take in logs or metrics from multiple different sources and use transformation on them. So it uses this thing called vector remap language, or VRL for short, where it can transform your payload and do modifications on them, and then use that modified payload to send it to the upstream sink. And those upstream can be S3, Elasticsearch, Prometheus, or whatever. In this demo, we'll use Loki as the sink. So what basically this vector pipeline is just consists of 3 main parts: sources, transforms, and sink. So now we'll go through each part of the pipeline to understand it better. I have a vector configuration with me. It's written in Toml. So first part is the sources. Over here you can see that we have Nomad events as a source name. It is of the type HTTP. What this means is, it runs an HTTP server on this port 3333. This is also the same port that we use in our HTTP provider API. So our program is sending events on this endpoint, and Vector is receiving them on an HTTP server which is started by this source. So now once this part is done, we'll go to the second part, which is transformation. So transformation basically means that you saw that how you saw how this event is. It contains a lot of extra metadata that we don't really need to log in Loki. So what we do is we only take the relevant part of the event that we need, and we create a new payload, JSON payload. So this is a basic example of using VRL, vector remap language, where we take certain keys as it is, like topic, type, timestamp. We are taking as it is, but this is an allocation type event, so we only really need a few handful of keys in allocation. So we are just mentioning whatever we need, and then we are creating this final JSON object out of it. So for each event, this will happen, and Vector will do this modification for each event, which is sent to this API server. The third part is the sync, and this is the final part in the pipeline. We create a type of a sync type of Loki, where we tell that it has to send these events to this endpoint called Loki 3100, which is the Loki API server. And then there are a bunch of other Loki configuration over here. One of the main configuration over here is this labels. So if you have used Loki, Loki identifies incoming logs via a set of labels, and labels should be low cardinality, and they should ideally be static. So since these labels will always be present in any type of event, we have chosen them, and with these labels we will be able to query our events easily. This is basically a GraphViz visualization of the whole pipeline, of the vector pipeline. First part was Nomad events, where it was an HTTP API server, and then we use a strategy called routing, where we route different type of events separately. So why we need to do that is, since I mentioned that payload key will be different for each type of event, we need to do different transformations for each event. So over here you saw this transformation was for allocation event. Similarly, we have transformation for different type of events. Over here you can see this is for job, where we are collecting other job related metadata. This is for deployment, this is for allocation, and we do this for each type of event that we are interested in. And you can always modify this JSON payload to whatever you need it from the actual event payload. So once you do that, in the GraphViz visualization, you can see that we then output all the events to Loki finally. So no matter whatever transformation you have done to each event, they'll all come centrally and be stored in Loki. So now I'd like to do a small demo to show how this whole pipeline program works. I already have a Nomad agent running, the dev agent. So I'll just quickly start the other parts of the pipeline. So this will run Grafana, Loki, and Vector, all three of them, this Docker Compose file. And then I'll run my program. So you can see the program is running, and it has subscribed for different topics, and it has already pushed an event to a provider, which is and it has only pushed one provider, which means a second batch strategy, which was more than 5 seconds of the idle timeout happened over here. So we'll just quickly open Loki. This is the Grafana UI for querying logs using Loki. We can see we have received our node registration event, and this is the final modification of that event, whatever transformation we did. You saw how big this event was, but we only extracted a few keys that we needed, and then it is stored in Loki now. It is queryable. So I'll quickly start a new deployment to show other type of events that are generated when you run a deployment. So again, I have a Redis a Nomad file. You can see the spec here. It's a fairly straightforward deployment. It just spawns a Redis container, and that is done. So we should see other events also which have been pushed to the provider. You can see over here. These are the different events that it has pushed. So we'll see topic. Okay. Now we can see the Redis job that we did. The deployment is successful. How do we know that? We can see the status as successful. Topic is deployment. We can also query based on this. So this was a label. And in Loki, this is how you search by label. So you select what the particular label stream you want to search for. So we want to check all the deployment related events and nothing else. So we can see we have 3 deployment related events, and then we only want to see wherever the status is successful, the others have running. So once we query like this, we can see the events which are successful, and it can also do it based on multiple topics as well if you want. So we can do the same over here, successful. Yeah, and if you want, we can also query by JSON. So since this is already a JSON object, we'll use Loki's JSON parser, which will convert these log lines into JSON objects on the fly, and then we'll use some kind of a filter to query. So job ID was one of the keys which was present over in the logs. So we can see job ID we have queried by Redis, and then we can see all the Redis related jobs. If you are not bothered about other jobs, this is how you query using Loki's JSON parser. Now you can see the output of this query is noisy. Like we don't really want to see all these fields. Let's say we only want to see the client description. So we can clean up our search output using this thing called line format, and then we can give the template of the output format like this. This is like a Go template, and you can see whichever field had client description, it has shown us the output of that. So this is a really simple example of how we can use Loki to query these job events. Let's also do more experiments with it. What we'll do is we'll open the Nomad UI. We'll drain our node. So then we can experiment with those node related events. So here is an option to do that. So it says drain is completed. Let's go back to Loki and see our node topic, and then we'll select node drain as a type. Alright, so we can see the node drain strategy was set by the subsystem drain, and then it completed it. So this is also useful if you have a large cluster which you use for batch jobs, and you periodically bring up new nodes and drain older nodes. You'll want to see how much time the draining takes. So you can build a graph of node drain events using this particular Loki query. Over here you can see the node drain was completed, and scheduling eligibility is ineligible now. Let's also do the opposite, that is we'll make it eligible now. So I believe this is done. Now you can see as soon as I made it eligible, the event was generated for that as well, where scheduling eligibility is eligible now. So these are the different ways that Nomad events can help us monitor our cluster, and what it can give us additional insights apart from Prometheus monitoring, of course. There are different possibilities with event stream that you can use for your own use case. One of the biggest advantages of using event stream, which I personally think, is that if you trigger a new deployment, you don't have to query the allocation events or the deployment events or the evaluation events separately. You get all of those information under a single place. Then the second example, we already saw how we can get the node drain events logged in Loki. We can also put alerts on allocation reasons as well. So if the deployment was failed due to out of memory, it was killed because of that, or any other issues, we can put an alert on that. We can also have an alert where you have set a particular container image version, and someone is running another image version. It has changed across the deployment. You can create a webhook alert and send it to your chat applications as well. with it. So these are all the different ways Nomad events can give additional insights to a cluster, and this is how, like, with the help of Vector and Grafana Loki, we are able to build a complete end-to-end pipeline for collecting and storing these logs. And basically these events will prove very helpful in debugging your cluster as well. So alright, thank you for attending this talk. Thank you.